Materials science at CU is really the whole enchilada. I mean that both in breadth and in depth. We have 60 faculty, and that makes us one of the biggest programs, I think, in the world. But also, materials can sometimes be cast as the beginning of the food chain. You make the stuff, and then it's somebody else's job to go make a device and bring the device to market and have an impact. But because of the interdisciplinary program here, we have teams of people that start with fundamental molecule tweaking and get to we're going into human trials next year. And so that to me is the exciting thing, is students and professors get to work with the world's best across that whole spectrum of problems.
The MSc program is a great example of how we can organize around challenges and not departments. If we're trying to develop the next generation of energy efficient thermoelectrics or nanoelectronics, it needs researchers from physics, chemistry, materials, engineering, computation, data. And so the MSc program allows us to do that, allows us to create an environment where young faculty who are trying to solve hard problems can work together, and also allow students to experience teamwork, which is by far the dominant mode of work in the 21st century.
Our program looks new. We're 3 years old. Our first group of graduate students is just starting to graduate. But on the other hand, the Soft Materials Research Center, founded by Noel Clark and Dave Walba, is going on 25 years old. We have 4 members of the National Academy, which are leaders in this program, and that's got to be near record setting as well. So what's exciting to me is the newness and trying to make something better and to advance and create a great new thing. But it's really nice to be building on this incredible depth and this strength that's been built over years as an opportunity for the brand new faculty member or the brand new student that can come in and make a new lab with that new professor, but next door is an expertise that they can draw on that's unequaled anywhere in the world.
I'm a mechanical engineer with a background in soft matter physics, chemistry, and mechanics of materials. And a key theme of research in my lab is to try to develop actuators that mimic the performance of natural muscle. And we've recently introduced a new technology that we call HASEL artificial muscles. And HASEL stands for hydraulically amplified self-healing electrostatic actuators. And those HASEL artificial muscles, they match or exceed the performance of human muscle in every single category. And now the future challenge is to bring those rapidly closer towards practical applications, figure out things like mass fabrication and a pathway towards commercial options.
I'm a professor in mechanical engineering, and I work specifically on thermal and energy sciences. I have been working with Professor CUBoulder in materials science and engineering program is on thermal radiation control. Essentially, we develop a new material, and that material is called metamaterial that can reflect sunlight and in the meantime maximize the thermal radiation to the outer space. So if I have that particular material, I apply it on an object outside in your yard or something, backyard or something, you would feel like this material is self-cooling down, even under the sunlight.
Converting green to the red, you produce 50% more of the photosynthesis light. You get natural resources to work in a way to improve the crop yield, and hopefully we can improve the amount of food we can produce over the same amount of land. Or for my case scenario in Colorado, we can elongate the growing season for the greenhouses.
To develop the materials and then nanostructured media of the future, we need to see how they function. So we need to combine new microscopes with data handling, with computation, with synthesis, growth, and all of that is possible only in a program like the MSc program that brings together faculty and students with very different and complementary expertise.
Boundaries to collaboration at CU are non-existent. We share students across departments. 3 and 4 PI grants are more common than not. And it's literally why I came to this university. I interviewed here, and in several of those interviews, I filled up the whiteboard with ideas I wanted to work on during the interview. And that's clearly the place to be. It's fun to come to work every day because there's going to be a new thing you can attack.